This is an introduction to using basic file I/O with Python. We'll focus on the black headers, but the blue are also useful and something that's worth studying. Basically, we can get user input using the input command. N equals input, please enter a number. And when we run that, we get a little text box where we enter our number. So if I put in 5, then when we run n, we get 5. So we're storing it as variable n. Notice that this is a string though. 5 is surrounded by quotes. If we want an actual number, then we should surround that with the int function so that it will turn that string into an integer. Then when we output it, we get an integer. And if we want a floating point number, float, and then when we run it, we get 5.0. So int and float are convenient for converting strings into ints or floating point numbers. You can also use the str function for converting a number into a string. So with Numpy has a basic function called np.savetxt. It happens very often that we want to save a matrix to a text file. And a convenient way to do that is with np.savetxt. Suppose we have 3 vectors, t, y1, and y2, and we want to save those as columns to a text file. The first thing we need to do is turn those into a single matrix and combine them. So the function to do that with is vstack. You can think of one-dimensional Python arrays as being a row vector, and so vstack will vertically stack these 3 and combine them into a matrix where there's 3 separate rows. Now because we don't want to store 3 rows, we want to store 3 columns, we'll transpose the result of that. So the result of this vstack command is a vector with 3 rows, and then we'll .t transpose that to get the matrix data. And when we print out the shape of it, we can see that the shape is 10 by 3, so 10 rows and 3 columns. Now we've saved this. The command here, so the first one's vstack. When we want to actually save it, we do np.savetxt, and we give it a file name and the matrix that we're trying to save. So pretty straightforward to use. Save text. And we can see when we do that we in fact get a file called ty1y2. If we click on it, it gives us our time column, our y1 column, and our y2 column. Now notice that we don't get any kind of header that describes what these columns are, and we didn't get much formatting. They're separated by spaces, and the width is a little bit inconsistent. We can add extra parameters, extra arguments to the np.savetext command, and that's shown here. If you do help np.savetext, you can see all kinds of help information. But the basic arguments are the file name and the data, and then you can add format strings. So fmt is %10.5f. You can change the delimiter, you can change the header, you can change the comment style. So here we're gonna go ty1y2.dat data, and then we'll do 20 this format string, a delimiter, and we'll put a header on there. So the header is just the string that will be printed at the top. The delimiter will be a comma between the numbers, and then this format string tells us how to format the data. So in this case, the % indicates the format string and represents the number that we're printing, and then 20.15f. This will give the number in a width of 20 with 15 digits after the decimal point, and f for a floating point number. So if we run that and then go back to our ty1y2, we can see we get a format string at the top, so we can see what they are. Everything is lined up nicely. They're separated by commas. We have 15 decimal places, and then 16, 17, 18, 19, 20. So the width of each field is size 20. If you scroll down, there's lots more format, a summary of format strings. So here's a little table that explains how they work. And most of this was taken from the link given here. So you can use strings, or you can do integers, floating point numbers, exponential notation, pretty output, and there's other kinds of formatting options available. Okay, so that's how to save to a file, np.saveText, give it the file name, give it the matrix you're saving. And then if you need to create the matrix, vstack is convenient for that. There's also another function called hstack, which stacks arrays horizontally. It's kind of the parallel to the vstack function. Okay, we can read text from a Numpy file with the command loadtxt. So loadtxt just takes the file name, and then there's other optional comments or optional arguments. So here, because I saved my file, let's go ahead, we saved it as ty1y2.dat. Let's go ahead and read it in. So we go np.loadtxt, file name, and then because I used a delimiter of a comma, we're going to tell it that in my file the delimiter is a comma, and we'll save that as my data. So when we run that, we get my data back. So the same thing as this, and paste it into this my data. Numpy also has a binary file format that can be useful, especially if you want to include all the decimals and if you want to have smaller file sizes. And for that, the commands are np.save and np.load. So there's some basic file system manipulation. These can be very convenient, but they only work on Maxim Linux. If you're on a Windows machine, you need to use the equivalent DOS commands for this stuff. So we'll skip over this. There's more general. Glob is a really useful function. I use it all the time for getting a list of files. So import glob, glob.glob. This star means give me all the local files in my directory. And then so we get a list of our files, and then we're just going to print those files. For file and files, print the file. So you can see here's all the files that I have, and sure enough they're the same thing as these. 1, 2, 3, 4, 5, 6 it looks like. And that's what we've got, these 6, along with this hidden pi cache. So this is useful if you want to process a list of files in your system. Glob can just return that list of files. You can have complete control over your output with the open command, and here's the syntax for doing that. You can input from files. The read line will give you the current line in the file, and it'll go through. Each time you call the command, it'll grab the next line in the file. There's also read lines, and that will give you a list of all the lines in the file, and then you can process those individually. There's a nice split function which will split a line into a list of words. So the third line in the file, the split command will give me an array of the individual words, and I can loop through those and process them. And finally, so that there's the input command, and then there's np.saveText, np.loadtxt, and then we learned a little bit about the vstack function. And finally, let's look at a YAML file. YAML is a particularly nice input file format, and that can be very useful for setting variables for use in a code. And there's a link here for more information on YAML. If you want to use YAML, you import the library import YAML. And YAML is particularly nice in that you don't have to do a lot of complicated coding in order to get data from the file. We'll show how that works. Here's an example YAML file. When we run this cell, it will output a file called input.yaml, and there it is. If we open it, this is the YAML file. And basically, anything that starts with a pound sign is a comment, and then we can set off different blocks of the code using a keyword with a colon. So here I have a block of params, here I have a block of stream props, I have a block of init params, I have a block, and I have an array of dump times. Within this params, I have a seed, tend, row 0, chemmec file, and then each of these keywords have corresponding values along with comment descriptions. So suppose we want to read in the value of some of these parameters. The way that we would do that is we first import YAML, then we open the file, and I'm saving it as Y file. So Y file equals open input.yaml, And then YAML wants to load based on a file object. So this gives me a file object, and then we call YAML.load that file object. And then I also save that as Y file, so I'm using Y file in two different contexts here to save on variable names. But I could have called this my Y file, and then just change this to my Y file, like so. And that would work just fine too. So if we want to get the seed parameter, seed, then we do Y file bracket params bracket seed, because seed is part of params. So we go params seed separated by brackets, and the same for t-end. If we want the O2 composition, we have Y file stream props comp0 O2. Stream props comp0 O2, that'll return the value. So this is convenient in that you don't have to read every line, you don't have to search the file for the command string. The properties can be in any order that you want. You can read them multiple times, and you can also very conveniently grab one-dimensional and two-dimensional arrays. So dump times equals Y file dump times, and that will grab me an array of these dump times. I can also get other properties like XY data as Y file init params vprof, and that will save this two-dimensional matrix as a two-dimensional matrix called XY data, and I can output the corresponding values. So that's a very nice thing to do. When you use a program like Microsoft Word, for example, you're used to setting parameters using a graphical user interface. You go up and click buttons at the top and set parameters using those windows. If you don't have a graphical user interface, it's really common in programming to have an input file that contains all the parameters that the user would set. And YAML is a particularly nice way of grabbing those parameters and having the user set those parameters without having to set the parameters directly in the code like you would in a cell, for example. So that's an intro to using file I/O using Numpy.